We're going to learn about a very useful tool in probability called a possibility diagram. A possibility diagram is a visual tool used to list all the possible outcomes of one or more random events in an organized way. It helps us to see the sample space, which means that we can also see all the outcomes that could possibly happen. Let's look at a simple example of tossing two coins. When we toss two coins, here are the possible outcomes. Head and head give you head, H, H. H and tail, which give you HT. Tails and H, which give you TH. And tails and tails, which give you TT. We can organize this outcome using our possibility diagram. We write one coin results across the top and another coin result down to the side. Then we fill in the boxes to show all the combination. Each box in the diagram show one possible outcome. Together, they show all the outcomes that can happen that is a sample space. This diagram makes it easy to count how many outcomes there are, check if the events are equally likely, and how also calculate probabilities. Let's explore using the possibility diagram with this example where we have a combination of two random events, a spinner and a dice. Imagine we have a spinner divided into three equal sections labeled as red, blue, and green. We also have a fair six-sided dice with number from 1 to 6. When we spin the spinner and roll the dice, we get an outcome written as a pair. For example, green, 4 means that the spinner landed on green and the dice show a 4. So the outcome is written as a pair of the spinner results and the dice number. Now let's walk through some of the questions together. Let's first find the total number of possible outcomes. Spinner has 3 outcomes, red, green, and blue. The dice have 6 outcomes, 1, 2, 3, 4, 5, and 6. We know that the total outcomes will be equal to 3 by 6, which gives you 3 multiplied by 6 is 18. We want to find the probability that the spinner lands on blue and the dice show a 6. Here we know there's only one favorable outcome here, where the spinner is blue and the dice is 6. Therefore, that the probability of the spinner landing on blue and the dice show a 6 equal to 1 over 18. Now we have to find the probability that the dice shows an even number. Even number of the dice are 2, 4, and 6. Each of these three spinner outcomes can be paired with all these even numbers. So we have red 2, red 4, red 6, green 2, green 4, green 6, blue 2, blue 4, blue 6. They give us a total of 9 favorable outcomes, and the probability that a dice show an even number will be 9 over 18 equal to half. We have to find the probability that the spinner show red or the dice show number 1. Let's list all the favorable outcomes. When spinner is red, we have red 1, red 2, red 3, red 4, red 5, and red 6. There are total 6 favorable outcomes here. When the dice show a 1, we have red 1, green 1, blue 1, so we have a total of 3 outcomes. But note that red 1 appears in both groups, so we have to take care of these to begin. The total number of favorable outcomes will be equal to 6 plus 3 minus 1 equal to 8. Therefore, the probability of the spinner showing red or the dice showing 1 will be equal to 8 over 18, which is equal to 4 over 9. Now the last part, we have to find the probability that it is not green 3. There are two ways to do this question. First, you can look at all the different possible outcomes and find every one that is not green tree. You realize that there are 17 of them. This is actually a bit more tedious. Another way is for you to use the complement rule. Remember, the complement rule says that probability of an event find equal to 1 minus probability of the event. So we know that the possible outcome for green tree is only 1. That means the probability of the outcome being green tree is 1 over 18. Using the complement rule, we can compute that the probability that the outcome is not green tree will be equal to 1 minus 1 over 18, which gives us 17 over 18.